Hello students, welcome back to the 10th video of this playlist. So this video would be the last video of this playlist since we will be solving the last question from May 2024 P1 regional paper. So let's see what's the question number 10 is about, the last question of this paper. Okay, so question number 10. So the concept behind this question is basically from differentiation that is discussed in chapter number 8 of your P1 textbook, and also you need some concepts from chapter number 5, that is straight line graphs, like finding straight line equations, the equation for straight lines, these stuffs. So in order to be able to solve this question, definitely you should have solved sufficient questions from chapter number 5, that is straight line graphs, and also chapter number 8, that is differentiation of your P1 textbook. Okay, so let's get started with question number 10. So here the curve C has equation y equals to 2 over 3x cubed negative 25x negative 56 over x plus 194 over 3, where x is greater than what? 0. The point P, which lies on C, has coordinates 2, negative 8. Okay, the point P lies on C, on the curve C, and its coordinates is 2, negative 8. Okay, now part A asks to show that an equation of the tangent to C at P is y equals negative thrice x negative 2. So basically we need to find out the equation of the tangent to the curve C at point P. Okay, so finding the equation of tangent. Okay, so we know that a tangent intersects a curve at a single point, and the gradient of the tangent is the same as the gradient of the curve at the point of intersection. So that means at first we need to find out the gradient of the curve at point P. This is how we can find out. We can find out by differentiating the equation of curve C. We will get what? We will get the gradient function, the derivative of curve C, and if you put the x coordinate of point P into the derivative of the curve C, you will get the gradient. So let's do that. At first what we will do, we will differentiate what? The equation of curve C. So what's the equation? That was y equals to, okay, that is you can do here dy over dx. Okay, we need the derivative of the curve C. 2 over 3. In differentiation what we do, we multiply the coefficient by the power of the variable. So here the variable is what? X. So 2 over 3 times 3, that would give you 2, and from the power of x we will subtract 1. This is the method for differentiation. So 3 minus 1, that is 2. Okay, twice of x squared, then negative 25 times 1, that is 25, and x to the power 1 minus 1, that would give you what? 0. X to the power 0 is what? 1. So that's negative 25, and then negative 56. It would be better if we had if we had shown, like, take out the power at first. Okay, just it would be better if we take out the power at first. So y equals to what? 2 over 3x cubed negative 25x. Take out the power at first. That's better for your differentiation method. You can do it more clearly. Negative x inverse 1 plus what? 194 over 3. Now you can differentiate using the method. Dy over dx would be what? 3x squared, 1 subtracted from the power, negative what? 25, and then the power is negative 1. So negative 1 times negative 56, that would give you positive 56. X to the power minus 1, that would be negative 2, and derivative of a constant is what? 0. So we got the derivative of the curve C. Now at P, what would be the gradient of the curve? What? At P, x equals to what? 2, right? At P, the x coordinate of curve is 2. So dy over dx would be what? Thrice of x, sorry, it would be twice of x squared. Okay, twice of x squared. So if it's twice of x squared, x is what? 2. So 2 squared is what? 2 squared is 4. So 4 times 2, that is 8, negative 25 plus 56 over 2 squared. That is 56 over 4, right? So now add them up. 25, 8 minus 25, there is negative 17 plus what? 14. So negative 17 plus 14, that is negative what? 3. The gradient we got, this is what? Negative 3. So the gradient of the curve C at point P is negative 3. So we know that the gradient of the curve at point P is the same as the gradient of the tangent at point P. So gradient of tangent at point P is also negative 3, and it passes through point P, which is 2. The y coordinate was negative 8. Negative 8. So now equation of the tangent. So how can we find out the equation? Equation is equals to what? Y minus y1. So y minus 8, that is y plus 8 equals to m times x minus x1. We need in the form y equals to mx plus c. So y equals to negative 3x. Y equals to what? Negative 3x plus 6, and take 8 plus 8 to the right, it will be negative 8. So y is what? Y equals to negative 3x minus 2. This is the equation of the tangent to the curve C at point P. Okay, so next, negative 3x minus 2. That's what they have asked for. Okay, for part B, they are asking the point Q also lies on C. The point Q also lies on C. Okay, given that the tangent to C at Q is parallel. It's what? Parallel. If parallel to the tangent to C at P. Understand? The tangent to C at Q is parallel to the tangent to C at P. So we already know the equation for the tangent to the curve C at point P, and it has a gradient of negative 3, right? Right? The gradient of negative 3. Now we know that concepts from chapter number 5, straight line graphs, the gradient of parallel lines are equal. So that means the gradient of the tangent to curve C at Q is what? It's also negative 3, since it is parallel to that tangent. So okay, so we got that concept. Now the question asked here in part B, that find using algebra and showing your working the exact x coordinate of Q. Okay, so for finding the x coordinate of point Q, we need the equation of the tangent to the curve C at Q, right? Okay, so the tangent to the point C to the curve C at Q is parallel to the tangent to C at P. Okay, so since it is parallel, so the gradient of that tangent would be also what? Negative 3. Okay, so since this is the tangent, we know that the tangent where it intersects the curve at that point, the gradient of the curve is the same as that of the tangent, right? So rather than finding the equation of the tangent at Q, okay, we can do one thing. We know the derivative, right? We know the derivative of the curve C. So since we know the derivative of the curve C, so derivative of the curve C represents what? The gradient of the curve. So at point Q, the gradient of the tangent is what? Negative 3. The gradient of the tangent is what? Negative 3. That means the gradient of the curve would be also negative 3, right? So what we can do, we can equate. What we can equate? We can equate that dy over dx. Okay, it was earlier. So for part B, we can write what? For part B, we can write at q dy over dx would be also what? Negative 3. Okay, so what was the derivative of the curve? The gradient function of the curve was it was in part A 2x squared negative 25, 2x squared negative 25. So it was 2x squared negative 25, and then what? Plus 56 over x squared. 56 over x squared. This can be written as what? This can be written as equals to negative 3. Fine? Okay. So what we can do now is that we can multiply both sides by what? X squared. Okay. So if you multiply both sides by x squared, what you will get? You will get here twice of x to the power 4 negative 25 x squared plus 56 equals to what? Negative 3x squared. We multiply both sides by x squared. So now take all of the terms to the same side. 2x to the power 4 negative 25x squared plus 3x squared. So that would give you negative 22x to the power 4. Sorry, x squared plus what? 56 equals to what? 0. Okay. Now divide both sides by 2. You will get x to the power 4 negative 11x squared plus what? 28 equals to 0. Right? Okay. Now let's solve this not quadratic, it is quartic equation. We can write this as x squared whole squared negative 11 x squared plus 28 equals to 0. So what we can do? Middle term. Is it possible to do middle term? 7 times 4, right? 7 times 4 is 28. So x squared whole squared negative 4 x squared negative 7 x squared plus 28 equals to what? 0. So we can take x squared common from here. So if you take x squared common, then you will have remaining x squared negative 4, and then you can take negative 7 common from here. So you will get what? Again x squared minus 4. So this is the middle term. So x squared would be equals to 7 or x squared equals to what? 4. So either x equals to what? Plus minus square root of 7, or x equals to plus minus 2. Okay, fine. So we got 4 values of x, right? So now let's consider. They said x is greater than 0, right? That means we will ignore the negative x values, and already we know that the x coordinate of one of the point with the same gradient is x equals to 2, right? So that means at point Q the value of x will be what? Square root of 7, right? Because at P it is 2, so at Q it will be x equals to square root of 7. So we got the x coordinate of point Q, right? And I think that's what the question has asked for, right? The exact x coordinate of point Q. So we got the exact x coordinate of point Q is what? Square root of 7, since x is greater than what? X is greater than 0, and at P x equals to what? 2. That's why the only x coordinate that is acceptable for Q is what? Square root of 7. And that's what the question about, the part B of question about 10 is about. So basically you could, most of the students would have done another approach here, like finding the equation of curve, finding the equation of the tangent to C at Q. That's what I was approaching, at first I was considering that, but why I didn't consider that later on? Because if you are finding the equation of tangent q, tangent to the curve C at Q, then your working should be large. Yeah, it will be large, and it would not be possible to equate because the equation for the derivative, it is not that simple enough. Okay, so basically if you have considered the tangent, the equation of the tangent, then we would what? At first find the equation of the tangent to the C at point Q, and yeah, or there would be another problem that at point Q you would not be able to find out the equation of the tangent because the coordinates of the point Q is what? Unknown. Coordinates of point Q is unknown. Okay, so that's why this approach is not possible. That's why I didn't consider this. I stopped there after considering that fact. Okay, so that means the only method we need to do here in part B is that we will consider the gradient of the tangent equals to -3. So gradient of the tangent is equal to the gradient of the curve. So since we know the derivative of the curve, we can equate the derivative of the curve equal to the tangent, gradient of the tangent, that is -3, and solve for x. That's it. That's all about part B from question number 10, and that's the end of this playlist, since this is the last video of this playlist. So definitely if you have any problem in any part of this playlist or any videos of this playlist, feel free to tell it or to write it below the comment box, below in the comment box of that specific video. And that's all about this question paper, that is May 2024 P1 regional paper. Thank you.